Hello guys, welcome to the channel, and as I've said, I'll be doing the complete section of virology. I think there's a spelling mistake here. Viro. Okay, so we are just getting started now. And what I'm just doing is I've just given a scheme of how we are working the things, and I just plan to do the whole section of virology in probably 1.5 hours to 2 hours, as I've said. And I will be just posting this video when and where possible, so that you can keep the track of my work and how I plan and how I am working on my preparation. So the virology, it consists of mostly 6 parts, I think so, 6 to 7 parts, I think so. And we will go from the basics, and we will be going to the first we will discuss the basics, and then from there we will go discuss the individual viruses, and then to the end. So I will be just cramming like anything. I will be like fastly saying stuffs. Mostly 2 to 2.5 hours, that will be the time for virology as I planned in my premeditated plan. Let's get started then, and let's get started now. Yes, coming to the startings, we have just started it, and this is the general virology. Okay, so this is the general virology part 1. So coming first we have to know about the classification. So classification is first, right? Classification. Okay, so basic classification: DNA virus, RNA virus. So it's under DNA virus, have remember the and most predominantly my videos will be like a flashcard like type. Okay, so whenever you just pause the video, you will be finding it in finding the flashcard like, and you can try to recall from there. So coming to the classification, DNA and RNA virus is the gross classification. So DNA virus, only basic mnemonic, just we have to start with the basic mnemonics here: H H A P P P P. Okay, happy. HHA, heart, PPPP, 4P. So coming to the H is the herpes viridae and hepaviridae. A for adenoviridae, A for adenoviridae, and poxviridae, papoviridae, parvoviridae. Okay. So another one, B for bacteriophage. So coming to the poxviridae, we have variola, vaccinia, molluscum. Papoviridae for HPV, Japanese encephalitis, polyoma, and Japanese encephalitis and polyoma, and parvoviridae is the parvovirus. And then yes, HHAVP, coming repeat with me. So H is for herpes, herpiviridae, hepaviridae, adenoviridae, hepaviridae, herpiviridae, adenoviridae, poxviridae, parvoviridae, parvo, just don't confuse with that. Papilloma, Japanese polyoma, and HPV, parvovirus, parvoviridae, poxviridae, variola, vaccinia, molluscum. Okay, that is the DNA virus. So coming to the other organisms, like parvovirus B19 under parvoviridae, and herpes viridae, we have HSV, herpes simplex, herpes zoster, and herpes HHV. Okay. Then other organs like other viruses like Epstein-Barr virus and cytomegalovirus, everything comes under herpes only. And hepatitis B virus, that is hepatinoviridae, and adenoviridae, adenovirus. Okay, that's it. So we have just done with the DNA viruses list now. Then coming to the other things. So specular things about poxviridae. So poxviridae is the largest virus, 300 nanometers. 300 nanometer size. It is the largest virus. So we have poxviridae, variola, vaccinia, molluscum. Okay, VVM. So variola, vaccinia, molluscum, papoviridae, human papilloma virus, polyoma, and parvoviridae, parvovirus. Parvovirus is the smallest. Pox, I will just write here. Pox. So Pox is the largest, and parvo. Just try remembering it from here. Parvo is the smallest. So smallest means 20 nanometer, largest means 300 nanometers. And then I have just explained the other things. Okay, just remember poxviridae, we have a VVM. VVM means variola, vaccinia, and molluscum. Then Papoviridae, papilloma, polyoma, parvoviride, parvovirus, herpes, HSV, herpes simplex, herpes zoster, cytomegalo, Epstein-Barr virus, and HHV, and hepatinoviridae, hepatitis B virus, adenoviridae, adenovirus, bacteriophage. Okay. Then other all organisms are RNA only. Just to remember, other than this, everything is under RNA. Okay. Okay, so coming to the I will just go through glance through the names of RNA viruses. Picarno virus, paramyxovirus, calciviridae, togaviridae, orthoviridae, bunyaviridae, flaviviridae, arenoviridae, corona is an RNA virus. Okay, coronaviridae, reoviridae, rhabdovirus, it's an RNA virus, and retroviridae and filoviridae. Okay, so size. Next, we have just said now, pox is the largest virus and parvovirus is the smallest virus. How is the size is first of all determined? So size is determined by ultrafiltration, ultracentrifugation, and electron microscopy. Okay, ultrafiltration, ultracentrifugation, and electron microscopy. First we are filtering it, then we are centrifuging it, and we are microscopy. Electron microscopy. So this is it. Okay, then so next I already said that the largest is the pox, the smallest is the parvovirus, and then coming to the shapes of the virus. So we have studied the size, then to the shapes. So rabies is the bullet, pox brick. Okay, pox look like boxes, so brick. Then Ebola is a filamentous virus. Okay, Ebola is a filamentous virus. Ebola, everyone tend to forget it easily. Okay. Ebola is the filamentous virus. Then tobacco mosaic virus, so tobacco is in a rod shape, so rod. Adenovirus is a space, from the name you can guess. Astrovirus is also star, you can guess. Rotavirus, wheel, you can guess. Coronavirus is a crown, so the petal, we have flowers in petal, right? So flower shaped papillomas is the coronavirus. Okay, corona is the petal, that crown, so petal shaped papillomas. Then rabies bullet, pox brick, Ebola filamentous, that is important. Then tobacco is the rod, and rotavirus is the wheel, adenovirus is the space vehicle, astrovirus is the star. Okay, so that's it for this thing. Then if possible, try googling the images. In the bullet shaped images, like it will be very much easy. The virus is the bullet bullet shaped means can you easily remember it's the rhabdovirus and the shape is the bullet shaped, and the coronavirus is the petal papillomas. Remember, petal shaped papillomas, coronavirus crown. So virus is the coronavirus and shape is the that thing. Then brick, so brick like color, that will be more of in the grey color of rabies in case of the box virus, bullet shaped virus, and in pox virus that will be like more of a particular tinge will be there. So with that you can say the double shaped DNA. So double shaped DNA virus is the pox virus. So you can just and also two layers will be visible there. Okay, double shape is there. That's very very important. Okay, I will just do double. Dumble means pox. Okay, then coming to the other. Then what is the other double shaped in other dumbbells? Okay, other dumbbell. I will just have a question mark here. So other dumbbells I have seen in asbestos bodies is a dumbbell. Okay, A for asbestos bodies is in dumbbell. P for pox virus we have studied is a dumbbell, and calcium oxalate. C, and then S, schwannoma, spinal cord. These are very very important. So other dumbbell shaped they are like, first we have asbestos bodies, and then we had P for pox, we studied that pox, and C for calcium oxalate monohydrate crystals, and last one is for the schwannoma, APCS. So this is the mnemonic here. Then coming to the Ebola virus, remember that is the filamentous virus. Okay, then rotavirus, wheel shaped virus, you can guess children, and then children is a diarrhea type virus, and the space vehicle is the adenovirus, you can remember. Astrovirus, very beautiful virus, star shaped virus. Then filamentous Ebola virus only. Then coming to the structure. Okay, so structure, it is the basic structure only. It's a nucleocapsid. It has a nucleocapsid inside. It's a viral genome enclosed by an nucleocapsid and surrounded by an envelope, and that is surrounded by an capsid. Okay, so nucleocapsid, envelope, and capsid. Then coming to the nucleic acid. So nucleic acid is DNA or RNA. It can be both. It can be both in case of bacteriophage, but here it is only either DNA or RNA only. So the structure we have just studied, and then coming to the then the DNA or RNA. So DNA we can have that happy mnemonic. Can you remember happy viridae, hepatnaviridae, adenoviridae, bacteriophage, parvoviridae, poxviridae, papoviridae. Okay. Pox largest. Pox is the largest virus. Can you remember the smallest virus? Small is the parvo. Okay. Then coming to the okay. So what I mentioned here means all are double stranded DNA. DNA viruses, everything is double stranded. DS DNA. But one exception. Whenever a question mark comes, there is a point there. So one exception being that it is the parvovirus. So what is that? It is a single stranded DNA. You are guessing the question mark. Okay, that's why I'm just not typing it here. Parvovirus is the double stranded DNA, except parvovirus, that is the single stranded DNA. Other everything happy is double stranded DNA only. Then coming to the RNA viruses. So RNA virus, what is the peculiar thing about RNA virus is that all have one copy of unsegmented single stranded RNA, except this is important. Okay, everything has single copy of unsegmented. Here normal is the double stranded DNA, where in DNA virus. But in RNA, single stranded RNA is only normal. I mean the most common most common thing. But the exceptions here is double stranded. So what are the double stranded viruses? So for that, how I will be writing means I will be writing SS RNA. It's the usual, only the most common. DS RNA. I remembering that. So reovirus. So reovirus shows double stranded RNA, and then retrovirus shows RR. Okay, retro reo. Both are best friends. 2 copies of single stranded RNA. Reovirus shows double stranded, but retro is an old man. Rio is a new man, so he has changed himself to double stranded version. But whereas retro means old, so old. So usually everyone has one only, but he had 2. Okay, so then is the segmented RNA. So reovirus okay, retrovirus okay. Then coming to the segmented RNA. What is that segmented RNA? That is also a separate exception. Seg RNA. Okay. So seg RNA we have Bira. Bira is the mnemonic. Bira. So what is that? So what is that Bira means? Bunia virus. Influenza virus. Okay, Bunia, influenza, rota, arena. Okay, Bunia, influenza, rota, arena. Bunia, influenza, rota, arena. Arena you can influenza you can guess Bunia. Try remembering that. Rota you can guess arena. Remember that. Okay, that's it. Usually positive sense. Okay, then what is positive sense RNA and negative sense RNA? Positive sense RNA, it can directly enter, and you know that an mRNA from that transcription undergoes, and RNA is from the DNA RNA is produced, there is transcription, from the RNA protein is produced, there is translation. For this protein production, when there is a direct action by the RNA, that is positive sense RNA. When there is a negative sense RNA which is converted into positive sense RNA, and then a protein synthesis occurs, there is negative sense RNA. So usually everything is in positive sense RNA. Okay, everything is in positive sense RNA except so positive sense RNA except. So what is the mnemonic here? It is the Mr. Fab. Mr. Fab is only not positive sense RNA. So what is Mr. Fab means? Already Mr. Fab drinks beer. Just remember it that way. Beer means Bira. Bira means Bunia virus, influenza virus, Bira, R for rotavirus, A for adenovirus. Arena virus. Mr. Fab means myxovirus, rabivirus, filovirus, arenavirus, bunia virus. So arena and bunia is common here, and rabies you can guess, philo and myxo. Okay, Mr. Fab means myxo, rabies, philo, arena, bunia. Arena and bunia most common. Okay, just remember that two names, new names. Okay, new names. So except this, everything is only positive sense RNA. Then coming to the nucleic acid, it contains never both nucleic acid is formed. So largest genome is the retro. So retro is the old, right? Already said that it is double stranded and all. So it is retro. Retro is the largest genome. So similarly, the smallest genome is HDV to HBV, hepatitis D virus and hepatitis B virus. Okay, HDV to HBV. Okay, so these were the smallest genomes here. Then coming to the symmetry. So symmetry can be helical symmetry, pox, or maybe icosahedron. So that is the symmetry. Okay, so symmetry is an icosahedron, helical and pox symmetry. So icosahedron means all DNA except pox. That is the all DNA viruses are icosahedron only, and most RNA viruses are icosahedron only, except pox. So pox is in box shape, so it's a complex shape. Then helical. So helical is an tobacco mosaic virus, a rod shape. I said like cigar. So cigar smokes. So it comes in helical loops. So helical is a tobacco mosaic virus. Okay. So then coming to the envelope. So what is the envelope here? So what is the envelope here? So envelope is the something that surrounds the nuclear capsid, the lipoprotein called peplomere, virus derived and host derived also. Lipoprotein part in lipo is the host derived, lipo host, and then virus is the virus derived is the protein part. So this is called as the peplomere. Can you remember the virus? It has that petal shaped peplomere. So this is the coronavirus. And then coming to the envelope. So in the envelope we have envelope and non-envelope. So what is the basic difference? So basic difference, the enveloped virus is either sensitive, heat level, or pleomorphic. Okay, sensitive, heat level, or levelity, not stability. Sensitivity, pleomorphic, it can change its shape. That is the enveloped virus. Whereas a non-enveloped virus is not sensitive, it is heat stable, and maybe you can't say stable, we can say not heat labile and pleomorphic, not pleomorphic. Okay, everything is non here. Then coming to the enveloped and non. Then what is the examples of non-enveloped virus? So that is important here, and it is an important question. Non-enveloped. Okay, so non-enveloped. What does it? So what it just remember the names. DNA PAP. This is the mnemonic, and RNA parch. Okay, DNA PAP and RNA parch. So PAP means already we know that it is parvovirus, adenovirus, and from the happy we have to choose the PAP. So it is the parvovirus, adenovirus, and papovirus. And RNA virus we have to choose parch. That is very kind of an hefty work. So it is a picorna virus, astrovirus, riovirus, calicivirus, hepatitis A virus. Okay, so picorna. This mnemonic is a bit hard. Okay, just try to remember it. I will just even put a star double, and it's very very important question too here. So PAP virus. So PAP is for parvovirus, adenovirus, PAP, parvovirus. Okay, PAP becomes easy for DNA. For RNA, parch. So parch, picorna virus, astrovirus, riovirus, calicivirus, hepatitis A virus. Okay, try remembering it before from the backward direction. It is the hepatitis A virus, calicivirus, riovirus, astrovirus, and picorna virus. Okay, not as astro only and rio only, not retro, not they remember Bira. What is the area? A, arena. Bear contains area, so means arena. Then coming to the viral replication. So viral replication is mostly by the non-binary fission, and it is a very very complex step. Okay, non-binary fission, that is more than enough for you. Then coming to the steps involved. Excuse me. Yes. Then coming to the steps involved. So then coming to the steps involved in the viral replication. So viral replication, the steps involved is the adsorption, attachment. So last is the adsorption and attachment, which is the most specific step. Most specific step of the viral replication is the adsorption. Attachment between virus and host happens here. So that is the most specific attachment. First step, what is the basic attachment? Most specific step. Next, second is the penetration. So penetration by phagocytosis, there is a membrane fusion by in HIV, that is important and question here. And injection of nucleic acid by bacteriophage, that's also important here. Bacteriophage, okay. Bacteriophage contains DNA and RNA, and injection of nucleic acid by bacteriophage. So this contains penetration's basic concepts only. Then uncoating, that is very very important. Uncoating, the capsule is lysed by the host lysosomes, and because of that only this is the reason. And under the steps I will just mention this uncoating only, because everything you can guess, but lysosomal action we will tend to forget easily. Okay, then coming to the this step is absent for bacteriophages. Okay, this step is usually absent for bacteriophages because as there is no necessity for it, first of all, because in bacteriophages there is a direct integration between the viral particles, and direct injection of the nucleic acid material happens, that there is no need for it. So that is the reason. Then coming to the biosynthesis. So biosynthesis, what happens after the injection means there is a synthesis of the new virion, site of nucleic acid replication for DNA virus and RNA virus. For DNA always present inside the nucleus. Okay, so it's supreme, so nucleus only. And RNA, it's a cytoplasm only. Okay, for DNA, and also here also the exception is the pox virus. So already we have said that it has in the symmetry section it has the complex symmetry, not the icosahedral symmetry. And RNA virus, hetero and orthomixo virus. Okay, RNA is present in the cytoplasm, except its exceptions is the, I will just put a question mark here and here to mark the exceptions. Okay, so RNA virus, nucleus, pox virus, exceptions the pox virus, DNA, nucleus, pox virus, RNA, cytoplasm, retro and orthomixo virus. Then coming to the assembly. So assembly is by the packaging. So packaging of the DNA virus happens in the nucleus, basic common sense RNA by the cytoplasm. Then maturation and release. Lysis of the by lysis of the host cells, sometimes it releases, or maybe budding through host cell membrane also releases. So virion is nothing but an integration between nucleic acid and capsid. That is virion. Virioid means naked single stranded RNA with or without capsid. That is only virioid. Virion means capsid is on. Virioid means no capsule. We are having the nucleic acid. What is the nucleic acid? It's a naked single stranded RNA. That is why it is naked. Then prion. Prion is nothing but an misfolded protein without nucleic acid. Okay. So that is this is important here. I will just type it in a single line. Virion. Viroid. Prion. How many hours are we into this? Hopefully not long. Yeah. Okay. Then coming to the eclipse phase. So in what is the phase? The eclipse phase is the time of entry to the first production of the virus is the eclipse phase. In eclipse phase, the bacteriophage eclipse phase is the most small, that is 15 to 20 minutes, whereas in animal virus is 15 to 30 hours. Okay, bacteriophages, because of the direct injection, 15 to 30 minutes itself the nucleic acid is produced. With the first virus is produced, whereas in animal virus it is 50 to 30 hours. Then coming to the cultivation, very very important section. So cultivation is the animal inoculation. So animal inoculation, embryonated egg inoculation, and tissue culture and cell line. Okay, under this virus cultivation we have so virus cultivation. First thing is the animal inoculation. Example, Coxsackie virus AF comes first. So AF, flaccid paralysis. B, spastic paralysis. So Coxsackie in mice, so in suckling mice it is studied. AF, flaccid paralysis. B is spastic paralysis. So embryonic egg inoculation. So egg chorioallantoinic membrane. So what are we doing with the chorioallantoinic membrane is that chorioallantoinic membrane, vaccinia, variola, and herpes simplex virus 1 and 2. It is you have to just cram only, no other go. Vaccinia, variola, vaccinia VVH, okay, VHVH, vaccinia, vaccinia, herpes 1, variola, herpes 2, vaccinia 1, variola 2, yolk sac, vibro, bro, arbo, okay, yolk sac, arbo. Then other what is the other thing? It's amniotic membrane. Chorioallantoinic membrane. Amniotic membrane is the II. Amnio I. So influenza virus and influenza virus isolation we can use amniotic. So for the isolation part we need a complete amniotic cavity like. Then coming to the allantoic cavity is by the allantoid. So something special we are going to prepare here. It is the vaccine preparation for the influenza. So can you say the animal inoculation is the Coxsackie virus, suckling mice A, B, AF, BS, BS. Then coming to the embryonated egg inoculation is the chorioallantoinic membrane. Chorioallantoinic membrane is the vaccinia, variola, and HSV. Vaccinia 1, variola 2, and then yolk sac. Yolk sac is the arbovirus. Amniotic membrane is the influenza isolation, and allantoic membrane is the vaccine preparation of influenza. Then coming to the tissue culture, under tissue culture we have organ culture. So organ tracheal rings, coronavirus, very very important, recent trend question. Okay, so it mostly you can just guess from the name, coronavirus only, trachea rings. Then coming to the explant cultures. So explant cultures from the minced tissue, it is the adenovirus. Okay, explant adeno. Okay, adeno space, so space something extraterrestrial, so explant. Okay, cell culture or cell lines, everything comes under tissue culture. So tracheal ring, corona, organ culture, explant something to the space, so adenovirus, explant culture, and cell culture or lines. Okay, then coming to the cell line, primary cell line, secondary cell line, and continuous cell line. First thing I'm just finishing with the continuous cell line. So continuous cell line, unlimited cell divisions can occur. In secondary cell line 10 to 50 and primary 5 to 10. Okay, so primary cell line, what is the primary cell line? It is the rhesus monkey and humans are friends. So rhesus monkey kidney cell line, human amniotic cell line, and humans eat chicken, so chick embryo fibroblast cell line. Okay, so monkey, human, and chicken, just remember these three and you can guess from it. Rhesus kidney cell line, human amniotic cell line, and chick embryo fibroblast, and secondary cell line and continuous cell line. Okay, then coming to the secondary cell line, it is the human fibroblast cell line. Okay, earlier we studied about the chick embryoblast, but now we are saying the human fibroblast itself. So human fibroblast contain two big things. It is the MRC5, WI38. I am just mentioning this MRC5 and WI38. Just mentioning that, you can just guess from the names. Okay, just don't do anything more than that. So where it is the human fibroblast is used for? So human fibroblast is it's an just 2 points. Okay, it's an secondary cell line. Okay, and also where we are using it is cytomegalovirus. That is an important question. Very very important question. Okay, so just remember, you have to just human fibro. I will just write that human fibro. Can you remember? And then chick embryo fibro. Try remembering it, and you are done with the go. And coming to the continuous cell line, and I'm just having a star also here to say that this thing, what is that, okay, chick embryo cell line is the we saw about this primary cell line, secondary cell line is over, and coming to the continuous cell line. So continuous cell line, every other thing is the continuous cell line only. So HeLa, HK, KB, McCoy, Viro, Detroit, CI, LK, Chang, BHK. So just remember the names, just go through once, it's more than enough, you can easily guess from it. HeLa, Hep2, Kate, KB, McCoy, Viro, Detroit, BHK, Chang, Silk. Okay, McCoy, Viro. So everything sounds like a cell line only, like scientific cell lines. HeLa, Hep2, KB, McCoy, Viro, Detroit, BHK, Chang, Silk. Then coming to the inclusion bodies, very very important topics. Okay, inclusion body. Okay, so coming to the inclusion bodies are two types. It can be an intracytoplasmic and intranuclear. So intracytoplasmic we have Negri bodies, Bastian bodies, Guarneri bodies, Bollinger bodies, molluscum bodies. I will just say simpler ways to remember these things. And intranuclear, it's a Cowdery type A and Cowdery type B. Okay. So coming to the inclusion body list, so inclusion bodies is broadly classified into intracytoplasmic bodies and intranuclear. So intracytoplasmic, Negri. So Negri, rabies, you have to cram this only, very very high yielding and very very important. And Negri, you can guess, Bastian is the variola, and Guarneri is the vaccinia, Bollinger is the fowl pox. Just remember that Bollinger, Australian bowler, so he's a foul pox and fast bowler. Okay, and molluscum contagiosum for HP bodies, Anderson and Peterson bodies. In chlamydia trachoma, it's a Kawasaki HP, that is very different. Okay, and here is the molluscum contagiosum. So repeating the intracytoplasmic again, can you remember? Negri for the rabies, Bastian, variola, Guarneri for vaccinia. Just don't confuse between these two. Bastian, variola, Bastian, vaccinia, Guarneri. Okay, CG, vaccinia, C, Guarneri, and RPC, CG, Overton. Okay, so just remember these two cricketers' name. RPC, so Passion, Guarneri, vaccinia, because in Passion and these kind of questions, both options will be there. Vaccinia will be there, variola will be there, you have to choose. Just remember CG, that is RP. So RP for variola, Passion, and vaccinia, CG. So vaccinia, Guarneri. Then Bollinger is the fowl pox, and molluscum is the molluscum contagiosum. And coming to the intranuclear, so in intranuclear we have two types, Cowdery type A and Cowdery type B. So Taurus is the yellow fever. Taurus likes yellow, so Taurus yellow fever. And the Lips-Schultz, so above the genital area. So it is a type 1 that group, herpes group only. Lips-Schultz. So it's herpes simplex virus and herpes zoster. Okay, Cowdery A type also very very important. This information is very very important, high yielding. Polio B, you can make P into B, so bolio. Okay, then okay, done. Hope I am just done with the list, and I will just try saying it again. Negri, rabies, Bastiona, variola, Guarneri, vaccinia, Bollinger fowl pox, molluscum contagiosum, molluscum HP bodies, Taurus like yellow, so Taurus yellow fever, Cowdery type A, and Lips-Schultz HSP, and herpes simplex, polio virus, Cowdery type B. Then coming to any virus which contains both intranuclear and intracytoplasmic, can you guess anything? I will just have a both and question mark here so that for you to guess later. So it is measles and cytomegalovirus. Okay, then coming to the Auli inclusion bodies. Okay, so Auli inclusion bodies, and I will just say cytomegalovirus versus Reed-Steinberg cells, because both contain Auli. I will just have an owl here. So owl here. So Auli inclusion, cytomegalovirus. Okay, So cytomegalovirus, as I've said, that one clinching feature is that it is both intranuclear and intracytoplasmic, whereas Rauza is an only nuclear, and also in Reed Sternberg cell, something to do with the pathology. So pathology means pink, to have it that way. But the cytomegalovirus, no, it is not pink. So what is the other color? That is the blue. That is the difference. Okay. Otherwise, it is one and the same. When it has present in both cytoplasm and nuclear, it is cytomegalovirus. When it's present only in the nucleus, it is the pink. That is the Sternberg cells. Both is then owli only. Then coming to the Zang smear. So Zang smear. Then under Zang smear, we have multinucleated giant cells with faceted nuclei can be seen, and it is demonstrated for HSV, herpes simplex, multinucleated molding, margination of the chromatin. So chromatin margins can be easily depicted in the picture. Okay, multinucleated, it will be like a polymorphonuclear lymphocytes, that kind of stuff will be there, but it is a multinucleated. That is very, very important. 2 or 3 multi-nucleus come together, molded together, multinucleated, margins of the chromatin can be visualized. So that is the Zang smear. And coming to the Negri bodies. So Negri bodies is also sometimes, it is more specifically present in the cerebellum and hippocampus, because the previous questions are before 10 years it was like Negri bodies released, but nowadays which specific location of the brain is the Negri bodies, that is cerebellum and the hippocampus. So Negri bodies, okay. Negri bodies, just remember, and a dog catching food out there. Then coming to the Warthin Finkelty giant cell. Warthin Finkelty giant cell, which means many inclusions clubbed together, and also said that measles also has both cytoplasmic and nuclear inclusion, so you can use that as a hint. And one more thing you have to remember here, it is the, I will just H virus. Okay, so H2 virus, what is the H2 virus? It is the measles is only H2 virus, Warthin Finkelty giant cells. Okay, and next thing you have to say is the molluscum contagiosum. So molluscum contagiosum, it's a pox virus, HP bodies. So strain is the Floxin strain, because everything you will just remember this molluscum contagiosum, HP you will remember, pox you will remember, pox, brick DNA you will remember, that complex symmetry you remember, largest virus you remember, everything you remember, cup shaped lesion also you will remember, but stain, what is the stain here, that we won't remember. So Floxin. Okay, so Floxin and tartarate. Floxin and tartarate is the stain you will use here. So pox is the 300. Okay, you won't remember this thing, but you will remember every other thing. Flask shaped also. Okay. Yes. Then coming to the assays. What is the purpose of assays? Assays is to do physical property studying and chemical property studying, and a chemical property we can qualitative study and quantitatively study. Okay, so assays to know the infectivity. Basic is the infectivity is done. So physical methods is that I will just have only one ASSAY. Okay, I will just add only one thing, assays. Okay, what is the assay? Physical method is by the RT-PCR, electron microscopy. Chemical methods is by the qualitative endpoint assay, and quantitative plaque and POC. Quantitative plaque and POC. Quantitative is plaque and POC. Because in plague infection, okay, just remember the story. In plague infection, you don't necessarily see the infectivity of the cases. You will just rather you will see the total number of cases. So total number means it is the quantification. So quantification is the plague and POC assay, and the qualitative is the endpoint assay. So that is the difference you have to know here. And cytokines are produced by the host. So cytokines produced by the host are the alpha, beta, and gamma, and cytokines produced by the host is being used here. Okay, then what is cytokines produced is the interleukins, TNF alpha, and interferons. So under interferons only we are studying it here. The interleukins, TNF alpha, and interferons. Then coming to the alpha. So alpha is produced. Alpha looks like L. So alpha is produced by leukocytes, and beta looks like a F. So beta is produced by fibroblast. Gamma, it is produced by Th1 cells. You know that gamma, granuloma, Th1 cells only. Okay, so interferon. So what is the interferon? Alpha, and both are alpha and beta. This antiviral only. So interferon receptor is the alpha or beta receptor only. But for the gamma, it is the gamma receptor. So then where is the difference comes between alpha, beta, and gamma is that in the chromosome. The chromosome is the 921. Okay, the chromosome is the 9 and the chromosome for the receptor is the 21. So 921 is the receptor, whereas in case of gamma it is the 12-6. 921 here and 12-6. So that is the difference here. Then coming to the mechanism of action, interference has no direct mechanism of action. Please note. Everyone thinks that interference directly goes past the virus. No direct action. It induces the host cells to produce translation inhibition proteins, because RNA is being produced here and the protein is only causing the damage. So the host cells are signaled to produce translation inhibition proteins, TIP, okay, which inhibits the translation of the viral RNA. So as a result of which the protein synthesis or maybe the infective protein is not formed in the virus. So interference are host specific, not virus specific. Very important. Ample number of times repeated question. Okay. Then interference, we have to see the various other uses of interference also. So alpha interferon, antiviral, okay, topically used for rhinovirus, and systemically used for hepatitis B, hepatitis C, and hepatitis T, herpesvirus. So topical for rhino. Okay, so alpha, you know that it is an antiviral. Okay, just remember rhinoceros. So horn is there, so you have to give it topically only. So topical. Beta looks like B, so brain. Treatment is for multiple sclerosis. Gamma, from the name you can get a chronic granulomatous disease. Okay. So we have just successfully completed part 1 section discussion. Okay, I will just easily say the few topics in that section that we first discussed. We started with the discussion with the general virology, classification, DNA, RNA, DNA, HHAP, and pox virus, largest virus, smallest virus is the parvo, and then other names of the RNA virus, how it is determined, ultrafiltration, ultracentrifugation, that steps, and then largest, smallest, and then shapes of the virus, bullet, filamentous, petal shaped coronavirus, rota, astro, and then we saw advice to see how to identify the images coming to the structure, and then DNA virus, RNA virus, exceptions of the DNA and RNA. DNA virus all are double stranded except parvovirus is single stranded. There is single stranded RNA is most common single copy, but double stranded copy of single stranded RNA is in retrovirus, and double stranded RNA is the reovirus, and then it's our segmented virus Beer. So it is Punya, influenza, Rota, Arena, and positive sense RNA, negative sense RNA, exceptions of positive sense. Everything is positive sense RNA except Mr. Fab, Mixo, Rabies, filamentous Arena, Punya, and then nucleic acid, largest genome, smallest genome, and then virus we saw about that icosahedron, helical, and pox, and nucleocapsid we saw lipoprotein, lipo host protein, virus derived, and enveloped, non-enveloped. And enveloped, non-enveloped, we saw the basic characteristic features, and PAP, DNA, and PARCH RNA, and PAP for parvovirus, adenovirus, papovirus, and PARCH for the picorna, astro, rio, calci, and complex steps, viral replication, and adsorption, attachment, most specific penetration, phagocytosis, membrane fusion, injection, uncoating, lysosome lysed step is absent for bacteriophages, biosynthesis, new virions, site of nucleic acid replication, DNA is the nucleus, RNA is the cytoplasm, exception is the pox, RNA exception is the retro and orthomyxoviruses, packaging, maturation, release, virion, virioid, prion, then eclipse phase, time entry, smallest is eclipse phase, bacteriophage 15 to 30 minutes, animal virus 50 to 30 hours, animal inoculation, Coxsackie, AIF, parasite, B, spastic, embryonic egg, embryonic first corona, CAM, coronal membrane, vaccinia 1, variola 2, yolk sac, arbovirus, amniotic membrane, influenza, amniotic, anatoic vaccine, then organ culture, tracheal rings, explant culture, minced tissue, adenovirus, cell culture lines, and primary cell line, secondary cell line, continuous cell line, primary cell line, recess, human chick embryoblast, secondary cell line. Okay, so monkey, human chick, and chick embryoblast, human embryoblast, MRC5WI38. Okay, then coming to the continuous cell lines, all other scientific names, HeLa, Hep2, KP, McCoy, Virology, BHK, and this silk. And coming to the inclusion bodies, Nigri, Rabies, Passion, Variola, VRP, so Variola, and then CG, Vaccinia, Garneri, Fowlpox, Molluscum contagious, covered type B, Taurus, yellow fever, Leishmaniasis, HC, herpes simplex virus, herpes zoster, covered type B, polio, then both the measles and cytomegalovirus, we saw about the difference between a cytoplasmic virus and cytomegalovirus and wheat stem cells. Both the intranuclear and intracytoplasmic, they are only intranuclear, only pink color, blue color, smear multinucleated cells, modeling margination, negri bodies, rabies, cerebellum, hippocampus, warthin clinical giant cells, measles, fixed virus, measles, and the nitrogen organism, okay, and class-shaped division, cup-shaped division, stain, important stain I just mentioned, the floxin and the tartar stain, mosquito contagion, pox virus, and then assays physical methods, RT-PCR, electron microscopy, quantitative is for the endpoint assays. Important question is coming under quantitative, qualitative is the endpoint, quantitative plague number, okay, plague park, so it against alpha, beta, gamma, alpha, L, beta, F, T, F, so leukocytes, fibroblast, Th1 granuloma, antiviral alpha, beta, 921, and the mechanism of action, no direct action, translation inhibition proteins, host specific, and alpha virus are rhino, so topical, and Hep B, Hep C, and Hep D virus, and beta for brain, multiple sclerosis, gamma for the granuloma. Okay, so that's it. We have just completed the first part, and we are just then moving to the second part.